Hey Stats crew, it's Mr. C here, and in this video I'm going to do a problem very similar to the Nasonex problem. Basically everything word for word, except I'm going to be using some different values to help you out with generating the 10 columns, which would be your 10 different simulations. Now, just to let you know ahead of time, and I'll summarize this in the Blackboard announcement, I want us to assume in this video that 1,689 patients were given a placebo and that 3 of them developed the upper respiratory tract infection. And then with the other set of patients, I want us to assume 2,254 instead of 2,103, which is the value in the original problem. And I want us to assume that 9 of them developed upper respiratory tract infections instead of 6. So with those values, our placebo rate is going to naturally change from 2 out of 1,671 to 3 out of 1,689. All right, and of course, instead of determining whether 6 upper respiratory infections could easily occur, that number is going to get bumped up to 9 in this video. All right, so we'll go ahead and run the simulation in just a minute or two. Because the first thing I'd like to do is show you how to add column 10 into the sample editor here. What you're going to do is select Data Tools and select option 2 where it says Add Columns/Rows. You'll see that this little menu here pops up, and we're going to add 1 column and hit Pokemon Go. Just kidding about that. And just like magic, we have a column 10. Alright, so now on to the simulation, our very first one. Let's click Data. We'll scroll down to Uniform Generator. Now the sample size that we're going to want to use is based on the second set of patients, the patients that were treated with Nasonex instead of the placebo. Alright, with my tweaked values, that's 2,254. Minimum refers to the smallest number you want to see in either of these 10 columns, and the minimum for us should be 1. And the maximum is going to be based on the amount of subjects that were given a placebo. With my tweaked values, that's 1,689. Now, as for number of decimals, let's enter in 0. This way every column will have nice even whole numbers. All right, nothing to put for random seed. Once you have all this information entered in, you can hit Generate, and the software quickly generates 2,254 values that are ranging from 1 to 1,689. So we're going to copy this data into column 1. So what we'll do is select Copy, and I'll move this screen out of the way, and I'm going to go to column 1. And I left click the first entry. Now I'm going to right click the first entry and select Paste. There we have it. Alright, now let's go ahead to Data again. We'll do Uniform Generator. I'll re-enter the sample size of 2,254. Minimum digit 1. Maximum digit 1,689. Number of decimals 0. Generate. Copy. Move this out of the way. I'm going to left click the first entry in column 2. That's how we want it to look. Okay, we'll right click now and select Paste. Alright, I'm going to go to column 3, just get myself ready for that. Let's go back to Data, Uniform Generator, sample size 2,254. Minimum value 1, maximum 1,689, number of decimals 0. Generate, copy, right click the first cell in column 3 and paste. Alright, so I'll just continue to repeat this until all 10 columns are populated, and then we'll proceed to sort each of these columns. Click that out. First cell in column 4, Data, Uniform Generator, so on and so forth. Alright, so we now have all 10 columns filled in with 2,254 numbers each, and the numbers in each of these columns are ranging from 1 to 1,689. What we want to do next is sort each column in order of increasing size. In order to do that, one way you could do it is, let's start with column 1. I'm going to right click that and select sort with this column, and what we're going to do is we get a drop down menu for sort. It says all columns. I actually want to select the one column, and we're going to select one column or sort one column, and the column that we're going to be sorting is column 1, and you want this to be enabled A to Z so it sorts it in order of increasing size. Alright, so now go ahead and left click sort. Column 1 is sorted. Let's now right click column 2. We're going to sort with this column. Drop down menu is currently in the one column setting, which is good. We now want using column number 2, A to Z. Let's now select sort. Column 2 is sorted. Alright, I'll do one more and then just do the rest without any narration. So I'm going to right click column 3, sort with this column. One column only is going to be sorted, and that column is column 3, A to Z, so in order of increasing size, select sort. And there we have it. Alright, I'll go ahead and do the rest. Alright, so all 10 columns have been sorted in order of increasing size. Now we have to do the analysis part of it. Now I want to remind you that the placebo rate with my tweaked values is 3 out of 1,689. So what that means for us in terms of the analysis of the digits in these columns is that if we're seeing the digits 1 through 3, okay, those 3 digits are going to represent an infection, and we want to consider the total number of 1s and 3s in each column. Alright, so if you look at column 1, we have 3 3s. Alright, so in this column there are only 3 people that got an upper respiratory infection. Alright, in column 2 we have the digits 1, 2, and 3. All right, now remember, a 1 represents an infection, a 2 represents an infection, and so does a 3. All right, so in total, the number of people that got upper respiratory infections in column 2 is 3. All right, so far, we've not had a simulation in which case 9 people developed upper respiratory infections. Let's look at the 1s, 2s, and 3s in column 3. If you look in column 3, we've got a 1, a 2, and a 2, and then 3 3s. Alright, so tallying up this amount, we got 1, 2, 3, 4, 5, 6 people in this simulation that got upper respiratory infections. Let's look in column 4 to see how many people got upper respiratory infections. 1, 2, 3, 4, 5, 6, 7. Okay, so there are 7 occurrences of the digits 1, 2, and 3 in total. Alright, so in these 4 columns, we have 4 simulations in which case 9 upper respiratory infections have yet to occur. Alright, now let's look at column 5. We got 1, 2, 3, 4, 5 upper respiratory infections. So again, another simulation in which case 9 upper respiratory infections did not happen. Alright, only 5 of them did. Let's look at column 6. 1, 2, 3, 4, 5, 6, 7, 8, 9. Alright, so column 6 is a column for which we did have at least 9 people develop an upper respiratory infection. Let's look at column 7. we got 1, 2, 3, 4, 5, 6 people got upper respiratory infections in this simulation. In column 8, 1, 2, 3, 4, 5 people develop an upper respiratory infection. In column 9, 1, 2, 3, 4, 5, 6, 7, 8 people developed an upper respiratory infection. And in column 10, 1, 2, 3, 4, 5 people developed an upper respiratory infection. So, of all of these 10 simulations or these 10 columns, how many columns are there in which case we have 9 or more people developing an upper respiratory infection? There's just 1 out of the 10. So that's 10%. All right? So when you are doing your analysis and you have to determine, whether or not, in this case, 9 upper respiratory infections, could easily occur, right? You want to take the percentage of columns, in which case, there were 9 or more. In your problem, you're going to take the percentage of columns, in which case there were 6 or more, and base your answer on 5%. Okay, remember 5% is kind of like the threshold in order for something to be, significant or not significant. Okay, so in this video, 10% of the simulations had, an instance of which 9 or more people develop an upper respiratory infection. Now, since 10% is greater than 5%, we could say that it's not significant for somebody to, develop the upper respiratory infection, or it's not significant, or it's not unlikely, for people to develop, 9 or more people to develop an upper respiratory infection. So with that in mind, you want to determine, is Nasonex influencing the rate of upper respiratory infections or not? All right. So that'll depend on the values being generated in your columns. Just keep in mind that this video demonstration is using some tweaked versions of the values given in problem 5. So I think I'll leave it at that. Leave the rest up to you. Of course, if you have any questions, regarding either this video or the simulation, the official simulations that you're going to be doing in the analysis, feel more than welcome to contact me. Otherwise, I hope you find this video helpful, and have a great day.